Okay, so we're told that the equation x squared minus kx plus 1 is equal to 0, and it has two distinct real roots, and we have to find the possible values of k. So this is an example of a discriminant question. So what I mean is, when we're solving a quadratic like this, we know that we can use a quadratic formula, which states that x is equal to negative b plus minus the square root of b squared minus 4ac over 2a, where where we have the formula of ax squared plus bx plus c is equal to 0. So in this case, the discriminant refers to this block over here, the b squared minus 4ac part. As we can see, it's square rooted, which means that if b squared minus 4ac is less than 0, then the square root will become negative, and a negative square root is in the complex number world, which means that it will not be real roots. If b squared minus 4ac is equal to 0, then this plus minus thing over here is just irrelevant because plus minus 0 doesn't make a difference. So you'll only get one solution. If b squared minus 4ac, however, is greater than 0, then you will have two distinct real roots, as the third over here will be real, since the b squared minus 4ac will be a positive number, and square root of a positive number is a real root. So what we're going to do is just not even going to use the whole quadratic formula. What we're going to do is just use the discriminant. So b squared minus 4ac, which is our discriminant, must be greater than 0. So what we're going to do is we're going to equate b squared minus 4ac to 0 first, and then find the inequalities, because it's easier to deal with the inequality after we've found the critical points. So in this case, a is equal to 1, b is equal to negative k, and c is equal to 1 as per our equation. So coefficient of x squared is just 1, negative k for x, and 1 for the constant. Now substituting into our equation, we get negative k squared minus 4 times a, which is 1, times c, which is 1, which gives us k squared minus 4. So we're going to equate this to 0. So k squared minus 4 is equal to 0. Hence, k plus 2, k minus 2 is equal to 0. So k is equal to 2 or negative 2. However, we have to find the inequality sign, since we have to get it so that's greater than 0. And this involves just plotting points on either side of these values and then finding out whether they work or not. So in this case, if we draw a number line, so let's say this is 0, this over here is negative 2, and this over here is 2. We're going to write whether or not b squared minus 4ac is positive or negative in these regions. So if we pick 0 as our first value, since that's in between negative 2 and 2, it will determine whether or not greater than negative 2 and less than 2 is a possible domain for our solutions. So substituting 0 in as k, we get, we can just use this equation over here. So I'm just going to bring it over here. K squared minus 4 is equal to 0. If k is equal to 0, 0 squared minus 4 is going to be less than 0, as negative 4 is less than 0. Hence, we would say that anywhere between negative 2 and 2 will give us a negative value. And therefore, this region is wrong, because we want a positive value. So already we can start to tell that our answer will probably be on either side of these critical values. But let's just double check. So let's take positive 3 as an example. So 3 squared minus 4 is equal to, well, it's not equal to 0, but it is greater than 0, because 3 squared is 9, 9 minus 4 is 5, which is greater than 0. Therefore, this part over here is at least correct, above 2. Now let's check with below negative 2. So let's try negative 3. Well, negative 3 squared minus 4 is greater than 0 as well, because the negative gets squared out. So what this means is that below negative 2 is also positive. Therefore, the regions for which the values of k for which this works is k is greater than 2 and k is less than negative 2. It's important that we don't write k is greater than or equal to 2, because k is equal to 2 would give one real solution, since b squared minus 4ac would equal 0 if k is 2 or negative 2, and therefore our x would only be one solution, which would be basically just negative b over 2a, since the b squared minus 4ac would cancel out. So this here is our answer.